Yeah, so it's pretty big. So while it's in the recording, we might just as well show it one more time as this technique under a thermal picture.
The giant at 40.
Yeah, you can see here at the center of the wall, we have a temperature of around 40 degrees Celsius, which is enough to kill a lot of living organisms, really. And bees use that to kill a few of the scouting hornets, but probably will not be able to kill a few dozens of them because they're truly strong for their sizes, and they are able to sting without dying, unlike the bees. It's a famous property of them. Yeah. And the methodology for this lecture and the following lectures will be going through this website or some other website that teaches the C programming language to showcase how a programming learning session must be like. It'll be reading through this and then trying out what we have learned on the executable, just compiling it, of course. And let's start with what we have here. Now that is a skeleton of a C programming text, and it has syntax highlighting on, so we will be able to differentiate, better see our codes, and I will be hitting enter after that int or the data type or the return value of the function. I'll be hitting a new line because there are programming conventions, some bound to programming philosophies, even programming design philosophies, that people may choose to follow, at least in the least sense, in order to provide consistency in the source code of a certain program. They try to do certain things to a standard. Like, for example, you might see in org in the source code of, let's say, they don't we have we are able to display, yeah, I'm able to display the files here, yeah. Like, for example, in the code written by these developers called suckless developers, they choose to write the return value data type in a new line other than the function's name. And that's a convention for them, and they used it all throughout the source code and even throughout all of these suckless projects. And that may be the case for many of the style choices. These are for stylistic choices, not design choices for a software program. But be sure to pay attention to consistency while building your software. You know, if you like to put space after writing the name of the variable and then putting your equal sign and then another space, you have to do it for the rest of your program. Otherwise, it will be an inconsistency, which would not look good, and also which would annoy the reader of that source code. So don't do that. Pay attention to your standards and be sure to choose the best standard, really. I said these are aesthetic choices, but sometimes some of them tend to leverage the reading experience of the source code. Like, for example, this is, in my opinion, more unreadable than what we had before than this. And your eyes tend to recognize what is good or what is not for the reader. So by programming over programming, you'll get to know that as well about it. I'm really not in speaking mode today. didn't see that myself, but let's start with the variables, okay? The C variables. Variables are a concept that is rooted in many kinds of fields, areas of science and philosophy maybe, but in the most basic sense, it is something that is variable. I mean, it varies and it stores some kind of data, some kind of value to be used later on in some sort of context. Like, for example, you might assign the value x in a mathematical equation to be 2 and then use it while defining a function or an algebraic expression. We might say something like this in a mathematical context and then define x to be 2, then the first expression will become 8. So the variables are just names that store some kind of data. And when the name of the variable is used somewhere in that context, the reader or the executor or whatever or whoever the hell it is that is trying to go through this variable expression will understand that this name, that x, is denoting whatever at that moment is assigned to that variable through some means of assigning. In that case, we use the equal sign to assign a value to that variable name. And you might then ask, why don't we just write 2 times 3 but use a variable name? Well, because it's in the name. It has to vary sometimes to the context. You might, for example, want to get the input of the user, and you know let's make this more convenient. Okay, you might want to get the input of the user, so you won't know before running the program on the user's computer what the value inside of this user input variable is. So you cannot know what to print after that, and you cannot put something constant here because of this. Because of this, you cannot put something constant here. You create a variable that is able to vary throughout runtime, which is the time that the program is running inside your computer. You make the the data variable by the program, by the computer, by assigning it to a name, which is called a variable. And this is also beneficial for the fact that variables also vary from runtime to runtime and from device to device. One time you run this program, you may input the character A, and another time you may input the character B, and another time you may input the character 1. So it will vary depending on the context. So it is best to use a variable rather than constants. It is not best, it is necessary. Without these variables, you cannot do anything. So let's just demonstrate some kind of example how we use variables by first reminding us of the output of the execution of this program, which we wrote in the previous lecture, probably. And yeah, we have to change that to war. We use the name. And yeah, this is 1 plus 1, which is equal to 2. And now we put it over here to print that to the screen. You might recall this function from the other lecture, and it will print out the value 2, as you can see here. And we can change it however we like. We might as well switch 10, and it will output 10. There are types of variables. They're int, they're float, they're char. This is short for integer. This is short for floating point. This is short for character, which basically means the integer. The difference between these are the storage capacity that they occupy in the memory and the type of interpretation they have from the point of view of the programming language. First, let's start out with the storage thing. See data types. We write that down, and let's pull up this website now. We get the integer data type to be 4 bytes, which is int, the one that we've been using past whatever we've been doing at the beginning. Integer data type occupies 4 bytes in memory, which means that you'll be able to specify put numbers inside of this integer variable that can be stored in up to 4 bytes in the computer memory. 4 bytes is short for 32 bits. Every bit represents either 1 or 0. You might have heard the expression that computers run are able to understand only ones and zeros, which is a wrong expression, but something that makes you intuitively understand a little bit about the workings of this machine. Everything is stored in a model 1 and 0 state inside a computer. High voltage would mean 1 and low voltage would mean 0 from the perspective of the computer, and one signal and one signal only, one low or one high voltage, will be called a bit. So the most basic units of storing data inside a computer is called a bit, and 8 of these bits are called bytes. So byte is just a fancy word for 8 bits, and it is conventionally named like so because 8 is a no, it's just conventional named like so. So 4 bytes, which is 32 bits, if you do the multiplication, 32 bits are just 32 ones and zeros next to each other inside of your RAM, and they are representing some kind of number in the case of this integer data type, which is in between 2 billion what and minus 2 billion. You might just ignore this because in your Olympiad questions there will probably not be anything doing with the ranges or the memory storage specifications of these variables, but just know that its range is such big that you'll have no trouble in most cases using this. And also you might recognize that it is able to include numbers below 0. This is because, let's assume these are the 32 bits of the integer data type inside the memory, which are not, because obviously there are not 32 bits there, but let's assume there is. And what we do when we store an integer value inside the memory in C is that we specify the first bit, the first foremost bit. Of course, if it is the one from the leftmost or the rightmost will vary depending on whether you are using the little or the upper endian architecture, but this is not of our concern right now, which is a really detailed topic actually. And we will name the first bit to be the sign bit, which if it is 0, our number will be positive, and if it is 1, as in this example, our number will be below 0, which is negative. I'm forgetting words. And the number is actually what is represented through the bit that is coming after this sign bit. So this last bit, this first bit, is not included in storage to the value of the number we're representing, which you can now also infer that we actually, by storing whether the number is positive or negative, we are trading off some space to represent a bigger number, a bigger but positive number through one single variable. Like for example, this bit, if this bit was not used for signing purposes, we could as well just add it to that array of bits, which would in turn be able to represent a bigger number in binary, of course. But now in the case of the integer data type, we are using it as a sign bit. And you may just as well change it by writing uint, which is unsigned bit, which is short for unsigned integer. And you might also specify how many bits you want to include in this integer data type, because we've said, of course, that integer occupies 4 bytes in memory, but we might just modify this to be 8 bytes here in this example, or 2 bytes, or 1 byte. This is even possible. We express the number of the bits to occupy in the unit bits, not bytes. You're not writing that down, but just these are for you to learn how things work in a low level of understanding, because you will not be required to know all of these, or even concern whether the number is stored in the memory with a sign bit or not. You just write integer var equals 10 and you go on with your life. And if there's any person here that is not aware of how binary numbering works, we might just summarize it for them. Like for example, take this to be a binary number. You know, in our daily lives we use onlu sayı sistemleri, yani 23 yazdığımda mesela ben bunu şöyle açmış oluyorum. 3 çarpı 1 artı 2 çarpı 10, yani daha doğrusu 2 çarpı 10 üssü 0 artı 2 çarpı 10 üssü 1. Yani bu basamak arttırdıkça böyle onun katları olarak gidiliyor bu basamakların değerinin ne olduğu. Fakat biz bilgisayarda dediğimiz işleri basitleştirmek için öyle 10 tane voltaj seviyesi yapmayalım diye 2 tane voltaj seviyesi belirlemişiz. Biri 1 olsun, biri 0 olsun demişiz. İkilik tabanı kullanalım. Sadece 2 tane temsiliyetimiz olsun demişiz. Çıkarım yapabileceğiniz üzere bu da şey demek oluyor o halde. 1 çarpı 2 üssü 0 artı 1 çarpı 2 üssü 1, pardon 0 şurası, artı 1 çarpı 2 üssü 2 artı 0 çarpı, yanlış yapmıyorum inşallah, dikkatim o kadar dağınık ki bugün. Benim iyi bir uyumam lazım. Çok da yorulmadım aslında ama niye böyle oldu bilmiyorum. Bu sayının değeri buna eşit olacaktır. Böylece binary conversion da yapabilirsiniz. Tabii bilgisayar biliminde kullanılan başka tabanlar da var. Oktal taban var, 8'li taban. Yani şunu yapabilirsiniz. Tabii fark ettiyseniz 10'lu tabanda 10 diye bir basamak olmadığına göre 8'li tabanda da 8 yok. İkili tabanda da 2 yok. Yani sıfırdan 7'ye kadar, sıfırdan 1'e kadar olacak. Mesela şu da, buyur Eda.
Abi şey diyecektim. Sanki ikili sisteme çevirmek için bir şey vardı. Böyle bölüyordun. Sonra
Evet, sürekli olarak ikiye bölüyorsun.
kalan var. Ondan sonra tekrar bölüyorsun. O bölüm kısmını. Sonra tekrar bölüyorsun
En
diye.
sonunda sağdaki bölümden aşağıya tik işareti şeklinde, ters tik işareti şeklinde yazıyorsun.
Yani evet, öyle yöntemler kullanabilirsiniz dönüştürmek için, de dönüştürmeye hiçbir zaman ihtiyacınız olmayacak.
Olmayacak mı?
Yok, ben sadece binary deyince kafası karışanlar varsa diye bunları açıkladım.
Tamam.
Modüler aritmetik konusu eskiden lisede vardı galiba. Hatta direkt bunları yapmayı öğretiyorlar. Ödevlerde, sınavlarda çıkıyordu da. Sonra kaldırdılar. Niye kaldırdılar bilmiyorum. Yakında bir calculus. Neyse. Şu sayı mesela, bunu da aynı şekilde 8'lik tabanda açabilirsiniz. Bir de 16'lık taban çok sık kullanılır bilgisayar biliminde. Fark ettiyseniz hepsi 2'nin katları. Hexadecimal deriz biz buna. Bilgis 16'lık taban. Burada 9'dan sonrasını ne yapıyoruz derseniz şöyle yapıyoruz. D, E, F. 10, pardon. 10, 11, 12, 13, 14, 15. Yani şu sayı 9F'nin hexadecimal'da karşılığı şu oluyor. F çarpı 16 üssü 0 artı 9 çarpı 16 üssü 1, ki F de dediğimiz gibi burada 15'e eşit. Böyle tabanlar bilgisayar biliminde işimize yarıyorlar. Nerede kalmıştık? Integer. And if we go on with our integers, we come across the type character. The char, or as we call it, like so. The char is basically an integer that is fitted inside 1 byte. That it is a type of integer that occupies 1 byte, but is interpreted differently by the programming language to be a character. As you can understand from its name, it is used to store characters. It doesn't need to store characters. You might just as well use it to sum up two numbers, as can be displayed in this example here. There's nothing wrong with doing this. As you can see, it displays the decimal value of the sum of the variables var and var1, but char, the name char is used kind of like an indication to the codes readers, source code readers, that this variable is probably going to be used to represent some kind of text character, which are letters A, B, C, D, or parentheses, or exclamation point, or a point, a semicolon, whatever. It is an indication for the source code reader that that the variable in question will be used to display a character in ASCII, the table of characters, in the most basic table of textual characters in computer science, which we talked about in the previous lecture, but might just as well be used for integer calculations, as you can see in this example, because everything in a computer's memory is represented through numbers, and it is up to you to write a program to interpret them however you like. In this example, in this program, we've interpreted the stored values var and var1 in memory to be decimals. We've specified to the printf function, read these as integer values and display them as so. But if we were to change this to a char representation, if we tell printf to interpret this as kind of a textual character, it will then reach out to the ASCII table and ask it what 21 is equal to in as a textual character, and try to display it on our screen. It is up to us to interpret the values in memory however we like. You might be a little confused with how can we be able to interpret whatever is in the memory however we like, but we are actually able to do it. Just that we are we're scraping the surface of the programming just so less that we're not seeing the well-built layers upon layers of programs running below our level of understanding of computers, that are manipulating the memory in such ways to interpret them so differently than what we can even imagine. We're not seeing those, so we are not aware that memory is just a bunch of electric signals that, if interpreted through path A, is something completely different, and if interpreted through type A, type B is something completely different, which is the case for all of the standards and protocols, all the standard documents in computer science and electrical engineering and all of engineering. You have a file system on your hard drive, and it is specified in a document, in a standard, that the first entry has to be the name of the drive, and the second entry has to be the table of the partitions inside of the hard drive. And you read a document about a networking protocol, which says every packet sent through that network has to include a header which tells the purpose of the sending of this packet, and another entry that has to say whether it is containing an image or a text or something of an asking. There are standards everywhere that specify how a message, how a thing, how a data has to be interpreted by programming question, sorry, so that everything makes sense contextually. Other than that, there is no inherent meaning to anything inside of this bare metal scrap of thing. It is the interpretation that matters. And as you can see, this is equal to, as we can also check through ASCII, the 21 is equal to something of this thing, which is one of the special characters, escape character. Yeah, negative acknowledge. So if we try to, go a little bit higher to hopefully get something, yeah, making sense. And here we go. We have the equal sign equal to 61 in ASCII. Of course, this is in ASCII. In order to interpret things in, more advanced textual character tables like UTF, Unicode, we mean by that, Unicode data textual character table, you'll need to use some more advanced techniques, but they are not part of our program today, and not of our concern really. Another data type we have is floating data type, which is ondalıklı sayı. Yani virgüllü sayıları yazmak için bu float tipini kullanıyorsunuz. Şöyle bir şey yapacak olursak, bu arada Türkçe'de şunu yazmaya alıştıysanız, ne yapıyorum? Böyle virgül, ondalıklı sayıları virgülle yazmaya alıştıysanız bu saçmalığı unutun. Dünyada sadece bizde var bu. Niyeyse. Ondalıklı sayı noktayla yazılır abi. Böyle bir saçmalık yok. Buraya nokta koyuyoruz. Tamam mı? Bunu unutmayın. You put the point because you're writing a floating point number, and then you just assign it. You use it however you like. And if you ask me how this works, it is in memory, I guess, represented via the scientific notation of floating point numbers. So some of the bits are allocated to this type of number, and some of the bits are allocated for the second section of the scientific notation. Double data type we have, it is basically a floating point with more precision that occupies double the size that floating point numbers have. Again, you don't need to be concerned much with the amount of space that they occupy inside your computer, because probably you'll not be using or differentiating in between them, but just know that they exist. We have the void data type, which is nothing really. It is used in functions to represent that it will not return anything. Like, for example, I may write a function to a and define it to be doing some kind of a thing. This, and let's again use the conventional data type here to be char, and use this again. This one. we see that it prints out the number, but the function did not return anything, because we put the sign void here to indicate that we will not be returning anything with this function. Again, consistency. But if we were to do that, it would default to whatever that C standard is using for that version to return for a function that whose return was not specified. So you can use this size of function to get the the storage space that a data type occupies in bytes by passing the data type's only name as an argument to it. And yeah, that's about it for the variable types in C. You can declare a variable. Outside of a function, and you might not define it. Defining means assigning a value to it. You might not define it. You just declare it and then use it in another context, manipulate inside a function. This is done usually for consistency reasons, where specifying the variables at the beginning of the program may be better for the reader to read, to understand the code as a whole, or maybe it will be to specify the scope of the variable. Scope means in programming the space in which the variables are accessible. By that we mean, for example, this function foo has a scope of foo that it has access to some of the variables that the program has, and it does not have access to the other variables. Like, for example, if I were to define a local variable here inside main, or let's just do it vice versa. Let's just define a variable inside of this foo, and then try to pass it to try to use it inside of our main function, and you'll see you'll get an error here because the variable O is not defined inside of the scope of the main function. It is only defined inside of the scope of the foo function, therefore is only accessible by the scope of the foo or the other functions that inherit the scope of the foo, which in this case we have none of. But by declaring a variable at the very beginning of your program in a global space, you make it available for all the functions and structures inside your program to access it. And also this ensures that when you manipulate this variable inside of a function and then use it inside of another function, the manipulated value will be used. Like, for example, you see here. Declaring works so we might just give countless examples by reading through source codes, but we will not spend our time doing that. And you can also see that we are able to assign the value of a variable to another variable by just putting the name of the variable at the other side of the equal sign. And we can also add these two variables. But basically, you might think of this as wherever I can use a value, I can also use the variable name for that value, so that I can, for example, sum them up here without having to type 5 and 6 in the places of these names for these variables. You may just write X and Y. So wherever you are able to write the value of a variable, you might just as well write the name for it. Another example would be this. For example, let's just change to something familiar, and then we do that. Then, as you can see, we are able to put the name of the variable to wherever the value of the variable may also be passed. So this is it, multiple variables. Yeah, this is a basic simplifying notation, to be honest. You might just as well use that. You might also do this kind of thing. And yeah, this is also possible. Declare more variables, multiple variables at the same time. By the way, this declaring thing, what this actually does is it assigns a space in memory in the name of this variable, but it does not change it. So even if you don't initialize, even if you don't define the variable's name here and variable's value here, you just declare it. There is a value written inside the space that is occupied by this variable. So before writing anything down to that space, you might just use this variable as well, which is very unhealthy because you don't know what's inside it, and which is also illogical. Why would you do something like this before using that? You don't know what from where it has been used before, but just know that it does not create some space out of nothing that is completely empty and unreadable until some value is written inside of it. It just selects a free, by free we mean and not in use section of the memory, and assign its address to the name of the variable you're just creating. And as you can see, there's some random value here. If we run it again, there will be some other random value, but we have to do this. Yeah, they're all uninitialized values. The program put all zeros inside of this variable. Forget what I've said before. The C program initializes all of them to be 0. Okay. But again, if you want to use it as a 0, just do not hesitate and do this. Play it safe. And yeah, the variable names, I think you are able to get over all of these. It has to be, it can include whatever the character you want, but it has to be adjacent. No spaces are allowed. Space would mean another token in the interpretation of the language. And we have some real life examples here. You might just try this out yourself. And we have data types. Aren't there anything we haven't covered here? They're extremely detailed types of data in C as well that are available in most programming languages, really, and they have all their own format specifier, and also they have the modifications to their format specifier when used inside a printf function. For example, how much decimals to print after the point inside of a floating point number or whatever, but they're of no concern to us, really. If you wonder them, you might as well look them up on the internet, but we will not be going over those. This is showcasing the keyword const, which is short for constant, which would make it impossible throughout the rest of the program to change any of the variables because they're constants. As you can see, it says error assignment of read-only variable var2, and this is also a blockade put by the programming language. Just know that this isn't some hard-coded thing inside the processor. It is just the programming language interpreter's blockade that is blocking us from changing the space of the variable we specify to be constant. Okay, and after mentioning that, we might mention the macro define here. As some of you might know, macros are as explained in the previous lecture, part of the pre-processing stage of a programming language, and we've covered one till now, which is to include a library. This can be anything. Like, for example, if I were to write a denemet hash inside of this folder, which the programming language will look for, which the linker will look for to find such files to include in my program. I might just do that, but there's another macro we can define as define, which basically will replace wherever it sees this text with this. So even if you, for example, did this, it will not work, which I'm hoping to be true. My knowledge may be ugly, false. See? Assignment, an implicit declaration of function foo. What? Yeah. So it is I don't know how to explain this, so I'll just do this. It will change wherever it sees the text light with this with whatever comes after it, even if it was something like this, it will change with that. This is mostly used for, you know, speeding up the programming execution, but you try to modularize your program. I might define you know, this program to be built you know, I might define a variable called version, you know, to be 2.3, for example. The program's version might be 2.3. And instead of putting that inside of a variable, because every time a variable is called inside of a program while in execution, it consumes RAM power and processor power, which is in turn some kind of performance issue, even if it's, you know, something minimal. It was significant back in the day, and it still has to be to you as ethical programmers to not use your computer's resources abundantly, but to use them in a conservative manner. And back in the day, the computer resources were even more pricey, and the programmers did everything they could to optimize this program to use as less space as possible. So they, you know, for something like this, you don't need to use a variable because it will not vary. So you might just say, you know, let's use a const because, but it will again require RAM access, RAM power to run this inside of a source code, inside of an executable program. So you just do this define thing before compiling the program. It will replace wherever it sees the name version to 2.3, and you would be spared of the boredom of trying to change every inclusion of this keyword version inside of your program to 2.3 or 2.4 whenever you have to change it because you've used a macro that is a semi-variable, if you want to think about it like so. So let's move on with operators. We have arithmetic, assignment, comparison, logical, and bitwise operators. Now, let's go over the arithmetic ones quickly. You can add, by the way, don't forget the semicolons at the end of your lines. Except for the macros, you always have to use semicolons. You can add, you can subtract, you can multiply, you can divide, you can modulus, which is kalanını almak. Yani 61'e 61'e böldüğünde kaç kalıyor o. You can increment. This is equal. This is just a shortcut for this. Okay, it's just a shortcut for that. And also this is a shortcut for that. You know, it's only one for one. It's mostly used in loops where, you know, you have to increment it one every time, and you are not bothered with writing all of these. It's just a shortcut. These are arithmetic operators, nothing to fancy, and we also have the backwards version of this thing. It will not matter actually inside of most of your cases, but inside a for loop, how can we exemplify that? Actually, let's talk about this when we reach the loops. In our lectures. So moving on with the operators, we have assignment operators, which are, I think, pretty self-explanatory. X plus equal 3 is equal to this, and minus equal, multiply equal, divide equal, modulus equal. And these are the versions. By the way, this is exponentiation. Üstüne almak, x üssüymüş yani. These are will just memorize the shortcut, and we'll talk about them in a bit. Okay. These are comparative. What can we say? Operators. I'm forgetting all of the words I know today. They're mostly used in loops and if conditions and other kinds of this stuff. Like for example, this means if var2 is equal to, let's do this. And we might also do this. This is a pretty basic example, pretty bad example, but it gets the job done. Explaining you what it's are. And if you try to eliminate this, it will just mean bigger. But now it's bigger or equal to, but already we've excluded the possibility of var2 being equal to 2 here. So it is just equivalent now, this and that. And we also have this thing, which is var2 is not equal to. And let's just write it out. What? Yeah. Let's just this. And get this. What? Yeah, we have no Mac for some reason that leads to this. Yeah, var2 is equal to 2, as you can see here. And if we were to change that to, let's say, 3, ya ne konuşabiliyorum, ne yazabiliyorum gerçekten bana ne oluyor bugün? And it is also valid in negative values as well, as you can see here. And by the way, something I forgot to mention was neydi lan? Unuttum. Let's move on. And you implicitly saw how to use if conditions here. You just write the condition, the expression inside of this parentheses, the thing you want to check if something is true or not. If it is the expression inside the parentheses is therefore to check whether something is true or not, whether something is equal to this or that, whether something is bigger than this or not. And then if this succeeds, you put your code inside of these brackets here. But if it's just a one-line thing, you might omit these, but if it's even 2 lines or something bigger than 1, you have to put these brackets here. And other than that, you might also do this. This also works. And you can see here we got no errors. This is a good shortcut, I think, for aesthetic purposes. It also looks good. Let's put a line here. And yeah, I think that's about it. This is not elif. Please do not confuse it with Python or some other language. And we also have this. We can parenthesize the expression and put an exclamation point at the beginning to reverse what's inside this parenthesis as an expression, last. If this, for example, let's just run it and for yourself. Yeah, it says now water2 is equals to true, because this exclamation point, like for example, an expression might only be true or false. And right now, this expression is false. var2 is not equal to 2, as you can see here. But if we put an exclamation point at the beginning of a Boolean expression, which is short for something of a statement that can be true or false, if we put an exclamation point at the beginning of the statement, it would reverse whatever its value. If it's true, it will make it false, and if it's false, it will make it true. And this if condition will only work if the expression inside of the outermost parentheses is true. And right now, this var2 equals to 2 is false, and exclamation point reverses it to true. So the if condition, the first if condition works, and the working mechanism of these if conditions and any other kind of these condition things is that once the first one works, it will not check for the others, okay? Because it is read else if here, and some other keyword we might add here, else, which is if none of this has worked, do whatever is written here. And we also have expression, merging, var2 equals to. You might think of these expressions as questions, okay? You are asking a question, and when the computer answers this, it deletes this statement inside the parentheses and writes true or false instead of it, okay? Right now, this is not true, so computer will delete it and write it false, okay? And we add another expression through this, okay? Change that where what it was. Now, this means that this statement will be replaced by something. This statement will also be replaced by something, and the result of this thing will be true if and only if both of these statements are true. This is called AND condition, AND operator. And you put this in between Boolean expressions, and it will operate on these expressions and output true only if and only if both expressions are true. Even if one of them is false, it will output false. And this is maybe the opposite of what this is. This is OR operator. It will output false if and only if both of these expressions are false. Let's see these in action. Now delete that, and let's just first try the or with this. You can see this was false, but because this was true, and one of them has to be true in order for this to output true, this condition ran its code. And we might as well just exemplify this once again. The function of the exclamation point, and now it passes this thing. And let's exemplify this as well. Let's create another variable here. var3 equals 10, var2 equals -10, and var3 equals 10. Let's run this. As you can see, it ran, but even if one of them is false, it would not. Okay, these are the logical operators as exemplified here. And lastly, we have bitwise operators, and I will talk about them once we get out of this break. That is an excuse for me to answer my incoming phone call. Okay, let's continue then. For the bitwise operators, we've pulled up another website, which is Wikipedia. It's pretty good encyclopedia, if you ask me, because it represents the free and open source knowledge spreading of movement. Actually, it's a big product of this movement, and I use it pretty much on a daily basis. Not on an academic level. You're not able to utilize Wikipedia on such a level. It's for general culture knowledge on certain on the topic you're looking for, probably. In the C programming language, operations can be performed on a bit level using bitwise operations. Now, when you are reading a documentation online, and as we've said in the previous lecture, if you don't understand something, just Google it, and ask it online before watching YouTube videos, before asking on forums, and actually ask if any of these are not working, none of these are working. As a last resort, you must come to be using the forums, not even videos, and how to utilize a forum is explained very goodly in this document. So I will share that to you through the WhatsApp chat. But before that, I need to check whether okay, share that to you. This document, and if you find it interesting, you might also read this How to Learn Hacking document by the same person, Eric S. Raymond, who's a famous free software activist, free as in free speech, by the way, as we've explained in the previous lecture. In this sense, hacker does not mean to hack some things. It means to hack some things, but hacking back in the day had a different meaning, which is to, basically to learn the inner workings of the computers and computer systems. Bitwise operations are contrasted by the byte level operations, which characterize the bitwise operators' logical counterparts, whatever. All of these are operators. Yeah. Bitwise. Bitwise means instead of doing some things, when you read bitwise, you realize that if the operations have some kind of a counterpart in the bitwise, in the bit space, in terms of bits, in terms of these numbers, they must also have another kind of space which they can act on, that this is contrasted with, and you would be correct in thinking that the previous operators we've seen, like the and or not operators, or the pluses, minuses, these equals, all of these things act on the interpreted meaning of the variable. Like, for example, this checks whether this variable is equal to the decimal minus 10, because this variable is meant to be interpreted by the programming language as an integer, as a integer that can either be positive or negative, and that is in decimals. But in bitwise sense, the way it's stored in the memory, it is just bits, as we've talked about. They're represented in binary, and they can only be ones and zeros, and without interpretation, they're just garbage value of ones and zeros of various binaries. And bitwise operators breaks this wall of interpretation and just acts directly on the bits. Like, for example, when you not this in a bitwise sense, you do this, you put this operator at the beginning of this, and you not that, you act the not operator on this set of bits, we will get the result of this, which will be nothing, reversing all of these values into their counterparts. This was 0, this became 1. The 1 became 0, the 0 became 1, 1 became 0, and etc. The bitwise not or the not operator reverses the value of the variable, which is in this case is bits, and bits are reversed like so. And we have bitwise and. You can see the logic table here. If you were to and 0 and 0, you will get 0. 0 and 1, you will get 0. 1 and 0, you will get 0. And only if you would if you were to add 1 and 1, you would get the result of 1. In bitwise sense, you might associate with the this with the Boolean expressions we've talked about previously, and you would be correct because they all stem from the philosophical and mathematical logic, mantık. Yani felsefe okuyanlarınız varsa bilirler veya 9. sınıfta bunun ünitesi vardı. İşte buradan geliyorlar. Bununla da küçük bir ilişkileri var yani. Direkt aklınızda ilk canlanan türden bir ilişki olduğunu zannetmiyorum. Ama yani ikisini birbiriyle böyle benzetebilirsiniz. En azından işleyiş, en azından sonuçlarını görürken. Tamam. And bu ikisinin and'ini alırsanız tabii ki kocaman bir sıfır elde edersiniz. 1, 2, 3, 4, 5, 6, 7, 8. Çünkü 1 ile 0'ı endledin. 0, 1 ile 0'ı endledin. 0. Yani endlemek şöyle çalışıyor. Endlemek, orlamak ve XOR yapmak. Yani şu endlemek ve orlamak bit gider. Yani önce bununla bunu orlar veya endler buraya yazar. Sonra ikinci basamağı yapar, ikinci basamağı yazar. Üçüncü basamakları endler, üçüncü basamağı yazar. And etc. Now, for the bitwise XOR. And now these are not details, by the way. These may be on your Olympiad questions because there can be some fancy algorithmic questions asked through this, okay? And you have to learn that. Sorry. Yeah, bitwise XOR performs an exclusive disjunction, and you don't need to memorize the definition because you have the logic table here. It shows the output of the operation on every possible combination of the inputs. Like for example, if it's both 0, the output is 0. If and only if only one of them is 1 and the other one is 0, or if they're different to be expressed in a different sense, the output is 1, and other than that, the output is 0, okay? Performs an exclusive disjunction, which you can see here, or logical inequality is a logical operator whose negotiation is logical biconditional. You can understand from this that these all stem from the mathematical and philosophical field of logic, which is implemented in electronics, computer science as well. The result is 0 only when we have 2 zeros or 2 ones. XOR can be used to toggle the bits between 1 and 0. Thus, I equals I XOR 1. When used in a loop, toggles its values between 1 and 0. Toggling means switching back and forth in between those. Shifting operators. Now, these are a little bit more complex and advanced, actually. Shifting. How can we describe this? I think it may best be exemplified by that because it is visualing this. You know, this variable ch contains this value, and if you were to shift it to the right by 2 bits, it will cut out the rightmost 2 bits and replace them with the rest of it and put zeros at the beginning of the variable, because they were non-existent before, and the left shift does the exact opposite thing, shifts it to the left. Like for example, deletes these two bits, slides the following to the left, and adds zeros to the rightmost end of the byte. Now, I will not go into further examples with these things because these are best learned. Actually, programming as a whole is best learned by doing stuff on your own. Me explaining these for hours will not do anything good to you. You're just, here to act as a pathfinder to you. Watching isn't a good way to learn programming, okay? So we try to keep examples as minimal as possible and invest in explaining the logic behind how these work. Yeah, we've mentioned the Booleans, comparing values. Yeah, this is the exact same thing we've talked about. And you can see this is a pretty good example of how Booleans work and is represented or interpreted within a computer programming language. As you can see, this will be true as a Boolean expression, which is represented as 1 in computer terms, which will be written to the screen as 1 because we are formatting it to a decimal inside printf. Okay. And if else, we've covered that as well. And nested if, what is that? Okay, you can use if condition inside another if condition. It's as simple as that. I don't think we need to explain this. It is just pure simple logic. Okay, and we have switch cases here. This is pretty useful thing actually. Like for example, we may rewrite this previous expression like so. Why am I not putting indentations? Okay. I forget the brackets. I am forgetting a lot of things nowadays. Hopefully this don't last until my exams. And we have the default expression at the and so let's just do the indentation. By the way, indentations are not necessary in C programming language. You can just, except for these shortcuts here, which are devoid of brackets. And if you use brackets here, they will be inside the category of omitting indentations as well. If you just put them all in the leftmost side of the screen, nothing will miswork. It is just for the aesthetic and readability purposes that we put indentations at the beginning of the new bracket codes. Okay, case 2, printf part 2 is 2. This is as simple as that and as simple as it sounds. Okay, you just that pop that out, and you can see this is also a shortcut for if actually, and it is faster to write, easier to read, and more aesthetic looking in some certain cases, which you'll most certainly realize when you need to implement such a case, that it is just but it is basically if it does the exact same thing the exact same way in the assembly level as well, but it's just a different kind of syntax. When you switch to war 2, this ses olmadan hiçbir şey gerek yok. When you switch to war 2, and in the first case 2, this means if var 2 equals to 2, do this. If it's equals to 3, do this. If it equals to 4, do this. And if none of these work, do this. Let's try that out. Var 2 is not any of that. Let's change the var 2 to 2. I'm using a lot of 2s here. And yeah, we forgot the breaks. Breaks. This is something of extraordinary, I think, because if you don't use the break at the end of your case code block, it will continue executing the other cases code blocks without checking whether they're true or not. There's some interesting feature of the C whose inner workings I forgot, but just so you know that if you're not using breaks here, your statement will not work as intended. Okay, and you can see here all of these works. Quite nice. And we can move on with our next kind of syntax. Again, as I said, I'm trying to go over these as fast as possible because you'll only learn them by practicing them on your own. We're just trying to, create a path for you, okay? And sometimes explain the logic behind them. While loop is a loop, a loop is something that is done over and over and again. We again have a Boolean expression here, and inside of this code block, we put whatever we want, and it will be executing this for the rest of the time when the expression inside of this parentheses is true. This Boolean expression is true. Right now, we only put 1 because it is equal to true, and it is interpreted as an expression and whose result is true because it's interpreted so. But you can as well put any of the Boolean expressions we've showed you throughout the if statement, if statements and other kind of things as well. Boolean statements are interchangeable everywhere. You can use any of them however you like, combine them with the operators in any ways you like into any of the formats and code blocks you see here. And don't forget the brackets. Any code block needs brackets, just like any code requires the semicolon at the end. So if you run this, the Emacs will crash because printing hello world every second for printing hello world many hundreds of times for every second because there's no time break, so it will continue writing hello worlds.
Bağlantı bitti ama.
Okay, I guess you got the idea here. The same thing is valid for loops. For loop is a little bit different than a while loop. Just write the syntax for that. The for loop is structured as such that the first space before this first semicolon is reserved for initializing a variable to whatever the value you like. Then you will have a Boolean statement, which is the control statement for your loop, that it will be until it is not true, the for loop will be executed over and over again. And this last line of code here is executed after the for block, this whole code inside of this is done executing. So when you start the for loop, when the program comes here, it will first do this, the code until the semicolon, and then it will check for that. If this is true, it will execute that code and then do this E++. It increments the E by 1, as you might remember, and then we'll check for this again. If it's true, it will do this thing, and it will do this thing, and it will check again. For loop is just that. It is usually used for counting purposes, but there's a fine syntax here, which is just a show off, and is exactly the same thing as that. Okay. So loops are so, and we can replicate a for loop inside of a while loop like that as well. For loop is just a shortcut to while loop, really. Okay, and we have a do while loop as well, which is while loop, but it executes the code first. For example, in this while loop, it first checks for this condition and does this. But in a do while loop, it first does this and then checks for the value. So in a do while loop, you're guaranteed at least one execution of this code block inside of this brackets. And we have four. What do we have here? Do we have something interesting? Nested loops. Okay. Does it talk about the backward increment and decrement? It does not. Okay, it does not. And break and continue. These are just keywords. Let's exemplify that on screen now. If you put continue here and the computer encounters with this, it will return to the beginning of the loop without executing the lines below the keyword continue, and break will just break out of the loop. It will exit out of the loop and continue from below the loop's code block to execute the program. Okay, this is it for today's lecture. We've covered pretty much the basics of C programming. In the next lectures, we'll be looking at you know the functions as well. Yeah, we kind of squeezed it inside of our lectures, and we'll continue in our coming lectures with arrays, strings, a pretty good application, an important application of strings, arrays. Strings are that, and pointers, which is essential to understanding how memory and processors work. And we can also even link that to the how ELF executable linkable format, the executable file for the computer work. We can link pointers to any of the low-level stuff you see about a computer. It's a very advanced, very fun, and also a very hard topic. At least people say it so, but it is not. It is the deep dive into computer science. It's the gate for this deep dive. So be excited to encounter with these pointers. Why do I suck at speaking today? Any questions?
No.
Okay, how are we going? Any kind of ideas or something? The homework will be posted on the group, WhatsApp group. So I will now be ending the lecture here. Have a nice day. And the next week, no, I can announce it later. So goodbye.
Goodbye.
Oğlum benim bilgisayarın sesi kapalıymış lan. Siz konuşuyor muydunuz? Bir dakika bir daha konuşalım.
Şu an sesim geliyor mu?
Bak geliyor. Nasıl satayım ben nasıl hocam böyle bir şey yapmayayım. Tamam önemli bir şey var mı? Yoksa kapatıyorum ha.
Yok, zaten bir ben kaldım.
Hadi görüşürüz.
Ha, abi bir dakika. Ben